We're going to talk about deep learning, another very advanced topic, if you ask me, but it should be fun. Nataliya is joining me from Utrecht, I believe, or where are you dialing in from, actually, tonight?
I spent my quarantine at home in Den Bosch.
Oh, different part of the country, but still, same time zone, luckily.
Yeah.
So, welcome. You work for Heroes as a data scientist, and you've been doing a lot of stuff around AI. I know you've joined us before during the Global AI Bootcamp in December, and we've spoken before that even at a Global AI night in Utrecht. So can you tell us a little bit about yourself, what you're doing in your daily life, and maybe an awesome project you've been working on lately?
Yeah, thank you. So let me introduce myself. I'm Nataliya, work for Heroes as a data scientist, and I have a background in biomedical engineering, and that actually helped me with getting knowledge in computer vision and medical data science. And at Heroes, actually, I did together with my colleagues various projects related to AI. Also including deep learning and computer vision. Yeah, so for instance, the last Global AI Bootcamp, I presented a workshop about deep learning applied to face recognition. Yes, this time today I'm gonna tell about a bit different topic without images, but still very interesting, I hope. um, and yeah, so if you'd like, I can start actually.
Sure, go ahead. Yeah, let's get started.
Well, I'm not sure if you can see my screen
Yep.
right now. Yeah. So today I'm gonna talk about high accuracy prediction of raw material prices using deep learning. And in particular, I would like to talk about predicting plastic prices because recently at Heroes we finished a project for a quite big international client, pipe supplier, and that was very challenging but also interesting task. So actually predicting raw material prices like plastic and other crude oil derivatives has been a very wide topic nowadays and has been a wide topic for ages. And people actually use different approaches to predict prices. Use different techniques and a lot of intuition as well, of course. But so I wanted to say that actually it required previously, let's say 20 years ago, it required quite a lot of domain knowledge to be able to accurately predict this kind of prices. So if were not a financial superhero, you will never have even a chance to predict this kind of prices, like crude oil prices, plastic prices, naphtha prices, or whatever. But today, with development of all the artificial intelligence, we can actually use other techniques to help procurement management teams in these companies to come up with a better price prediction that will be not only based on human factor but also based on numbers, on data. So our task was to predict raw plastic material price for 2 months ahead. So not only one value but two values, right? 2 months ahead. So it's sounds quite challenging. We of course, by doing this project, we didn't want to replace the procurement management team and their analysts, of course, only to help them. So the our approach was to create a decision-making system that will help procurement management team to make better decisions on their price deals with their customers and so on. We actually that's very important to mention that prices are being generated, that prices of raw materials are being generated in quite interesting way. So in order to make these predictions, we need to dive into this business and to understand how these prices are being generated and what are the main price drivers. Because otherwise, if we will have something like intuition approach, we will actually following this lady maybe, but not following the structured approach. So in order to succeed in this project, we need to create a project pipeline, which in our case included business understanding, as I mentioned. We needed to dive into the business and understand all the business kitchen, understand what are the major economical, political, and business indicators that are actually very important for the prediction. And so after understanding the business, it's very important to collect the right data. Maybe it's even more important that actually build the model, build the final model, because if you will gather wrong data, or you won't get enough data, or your data will be irrelevant, it can, even if you will have a very sophisticated model, you will probably not get any good results. This steps actually very important. It includes a lot of interactions with the client and also some other methods that will help to understand all the hidden parameters and indicators that are probably will help you to build better predictions. The next step is to prepare data actually you got from the client and to analyze it. And the steps also include a lot of other steps like building correlation matrices and finding hidden relations in data that can help you. And only then you can actually start training model and at least selecting your model and trying in your experiments. After you train the model and receive the proper results, you can actually visualize the results and yes, so that on that stage, the projects will be near to finished. Yes, so understanding the problem. When we talk about crude oil crude oil derivatives like plastics, we are talking about quite complicated process. So the plastics we receive plastics from crude oil, but there are different stages between the raw crude oil and raw plastic materials, of course. So also from crude oil you can receive diesel and other petroleum derivatives, and there are a lot of complicated technological steps in between of getting crude oil and plastics. And of course all these steps, they actually has a big impact on the price of plastic. And of course, it's important to mention that we don't have only one type of plastic. We also have different types of plastics. You can use plastic not only for pipes, but also to create all kinds of stuff. You use plastic every day, yes. So, in different pockets, or I don't know, plastic bottles, wherever. So plastics is everywhere surround us, and that's also add another level of complexity to this project. With all the understanding of the domain that you can get, we need to actually collect the data. But to collect the data in the right way, you need to have a good interaction with the client, to ask sharp questions, and also to apply right approaches that you and your client are in line with all the terms and other factors. First of all, we set a brainstorm session with the client in order to find the most important price drivers that will help us to predict the future procurement prices of the plastic. And during these sessions, we used mind maps approach. Of course, this is one of the most interesting approaches when you actually visualize all kind of price drivers, and it's actually very interesting way, because the mind map, it's a diagram that actually helps you to visually organize information, and it is hierarchical, and it helps you to find to show relationships between pieces of the whole processes, and so we easily can visualize all the price drivers. For instance, for plastic, you have price drivers like import, export, supply, demand factors, various economical factors, business indicators, also crude oil spot prices, naphtha prices. So there are really a lot of different indicators, but how to really find out which drivers, which indicators are important, how to select them. And first of all, it's important to receive a business estimate. So what business side thinks is important. After that, we can actually select the final group of drivers that we will collect from our client and use in further analysis. And in our case, as I mentioned, it was supply-demand factors, crude oil prices, import-export, business climate index, and economic and manufacturer indexes. Also, some spot prices were also used in this project. So now we can actually move to data preparation and analysis. Data preparation and analysis part of my presentation. So now we have all the data collected from the client. Let's say we organize it in this data in data lake, so that client can continuously upload new data, and you can continuously get the new data from the client. And what are other very important facts? You need to think about sampling rate of your data. Like, what I mean by this, you need to understand how if you want to receive your data on a monthly basis or on a weekly basis, or let's say on daily basis, what is really important, it's also up to the it's also very important to decide with your client. For instance, in our case, we got both data on a monthly basis and on a weekly basis, because it was hard to understand from the first point what will give us better results. So we need to test both approaches. But in some cases, like when you deal with predicting electricity or other time series data, yes, because we are dealing with time series data. This data is changing over time. That means that it's time series data. In some other cases, you probably you probably will know this from the first moment. Like if you would like to predict electricity data, you probably need to receive it on an hourly basis, because it's very important to not to miss every hour in order to have more information, more data, and find more patterns in data and more hidden details. Of course, after we decided on a sampling rate, we also what we else need to do with data. We need to clean this data, of course, to full all the missing values and etc. And also, in order to prepare the data for before feeding the data to the model, to any model, you need to split the data into training set and test set. So that training set, it's a part of the data set, initial data set, that you will show to the model, and another part, test set, you won't show to the model, so you will evaluate your model on this part of the data. That's actually one way on how to evaluate your data. If you sometimes there's also an approach to actually train the model on the whole data set. In case if you receive your new data quite frequently, so you will know that now you train your model on the whole data set, and then you will in 1 month receive quite a big bunch of new data. Then you can test your model on this data, but it's quite rare situation, I would say. Most of the time you don't have a lot of time, so you need to deal with the data you have, and in that case the best approach is to split the data you have into training set and test set. So of course, also in order to prepare your data well, you also need to scale the data, because usually all the data units and scales are very different. So all the business parameters and indicators, they have for instance, values from 0 to 1, and all your prices are very different from this. So you need, of course, to normalize your data. And usually data being normalized in values between 0 and 1. So we also did it in our project, of course. There is actually it's quite a common step for data preparation. As I mentioned before, we are dealing with time series data. And when you deal with time series data, you actually have to ask yourself 3 very important questions. Is this data stationary? Is there any seasonality? And is the target variable autocorrelated? So why we need to ask ourselves these questions? What is actually stationary? What data called stationary? Stationary data, it's stationarity. It's an important characteristic of time series. Time series is said to be stationary if its statistical properties don't change over time. In other words, it has constant mean and variance, and also independent covariance. What data is called seasonal? Well, it's quite easy to understand from this name that it's the data that is changing from season to season, but so it has periodic fluctuations. Also another one a very important point is autocorrelation. Autocorrelation is a similarity between observations in the same data set. So if you have a period in your data set that actually is very similar to another period in your data, but let's say in another year, for instance. So it's you can see it as a function of the time lag between time, let's say. So also when you analyze your data, it's very interesting to see the correlation heat map. The correlation heat map, it's actually what you can see on this slide. We built a correlation heat map to see how different values of your data set are independent or not. So how many dependent variables you have. And usually you can actually do it also to exclude some values from your data set because it's actually quite there is a connection between how much correlated values you have in your data set and overfitting. So if you have quite a lot highly correlated variables in your data set, it's more likely that your model will overfit. But it's not a direct connection, let's say, but it's very it's what you can get from your experience. But it's also like if you for instance you can also understand it as for instance you have 2 or 3 highly correlated variables in your data set, and it actually means like you add 3 similar variables to your data set, like you just weighted one of your variables by the weight equal to 3, right? So that's actually not good. Definitely not good. So you need to deal with this and think how to overcome this issue. So that's another step in data preparation. So another way how to analyze your data is building a plot where you can see relations between all of your variables. And for instance, you can use, if you use Python for your data analysis, you can, I recommend to use Seaborn library. It's very handy and it creates quite nice visualizations. So In this plot, you can see relationship between variables, distributions, and also scatter plots. And you can actually investigate the correlation nature of your data variables. I would also mention that important thing is to notice how most variables are multimodal in their distributions, and it can be noted. That the relationship among the variables is not linear. And for this reasons, we hypothesize that linear regression, for instance, if we apply linear regression model for this data set, will not perform very good. So now we are actually very close to the next part. It's exciting part, models. Model comparison. Of course, when you are dealing with a new project and, for instance, you never experienced dealing with projects in this domain, crude oil domain, financial market price prediction, you always need to investigate what are common ways of predicting and compare all the modern approaches to predict prices. In our case, we compared three quite popular methods like multiple linear regression, autoregressive integrated moving average, and neural networks. So what can we say about multiple linear regression? It's quite simple model, but yet powerful. Multiple linear regression actually has multiple independent variables, and it actually one very multiple regression is quite common methods used when you have multiple variables in your data set, and it's actually based on reducing the least squares or on minimizing mean square error. So that actually means that multiple linear regression usually use the same loss function as a neural network. So it's quite easy to compare these models based on that. Also important to mention that multiple linear regression tends to overfit as the number of variables in your dataset increase. Another model we compared for this project is Ahriman, or autoregressive integrated moving average. It's quite more difficult model, let's say, but it's a very common model, econometric model that are widely applied for financial price predictions. Well, it was applied maybe 10 years ago, but now all the research papers show that people start to look into AI and actually select AI models to predict financial prices because they show better results. Well, it's not a secret. What are characteristics of Ahriman model? For Ahriman model, it's very important that data is is stationarized. So actually, from that point, we can already understand that probably if your time series data is not stationary, it won't work very good with your data. And most of the financial market prices are not is not a stationary data. Like if you deal, for instance, with predicting electricity, as I said before, or some other stationary process, that's very good model to use. But if you have a very high fluctuations in your data, very unreliable factors that can impact your data, like political crises or some wars between countries, yes, like it's what we have for crude oil prices, for instance, then Ahriman method probably not the best one, but we will see later. So, and what are the third methods? It's neural network and recurrent neural network in particular, because for time series data, it's better to apply not a regular neural network, but a recurrent neural network. What are the difference? Usually, a traditional neural network, it has input layers, output layers, and also hidden layers. So it works like forward propagating. And what's the difference between regular neural network and recurrent neural network? So the simplest form of recurrent neural network is similar to regular neural network, only it contains a loop, as you can see on this slide. It contains a loop that allows the model to carry forward results from the previous neuron layers, so that it makes it easier for recurrent neural network to learn the data, to learn the patterns in the data, how data changes in time or for a period in time. For instance, regular backpropagation takes the weights of the model in several iterations using training samples. And in recurrent neural network, backpropagation needs to take into account what the model is carrying forward. The model is carrying forward information from each neuron layer to the next, and fine-tune the weights that actually govern this short-term memory. And now we actually came very close to the main, main actor of the show, long short-term memory. And what's actually the big benefit of long short-term memory? Long short-term memory unit of recurrent neural network has advantage. It actually has not only one activation function as a basic recurrent neural network, but 4. So it has 3 sigmoid activation functions outputs numbers between 0 and 1, and lead to multiplication gate. And this gate determines actually whether information should enter the cell or not. So means 0 means no information enter, and 1 means all the information enter. These 3 cells are used to save pertinent information for later stages of the learning process, and in the training process, the network learns what are the optimal values for the gates. And and as I said, how much information should be retained to help the network learn. And here you can see the comparison between applying multiple variable regression, Ahriman, and neural network with LSTM layer to crude oil price prediction. This is a graph from one research paper. So here we see that actually in this research stated that the neural network works better for financial market price predictions such as crude oil price prediction comparing with Ahriman and regression. So we see that Ahriman on this graph has quite high outliers, especially when the crisis of 2008 happened. We see that the green graph is quite wide comparing with the neural network. So based on that, we decided to use the neural network with LSTM layers in our solution. And now I can go to results of our project. So in order to achieve our results, we also need to have a good not only to train the model and receive good results, but also to properly present our solution. And one of the main wishes of our client was to visualize the system in SAP, visualize the results in SAP. So we actually deployed our model as a Docker container, and we deployed it as a Docker container to Azure and configured it to be consumed by SAP. And that's what we received in the end, the visualization. So actually, as I said before, we split our data set into training and test sets so that our model never saw test set. It's only we left it for evaluation part. And but in visualization, we have to visualize only last 2 months, so that the client could actually compare the prices and use it for their own procurement stuff. But of course, we evaluated our model on a test set, and the final accuracy we achieved a bit more than 90%, which is actually very good for such fluctuating data set. But it also means that it doesn't mean that it will work perfectly during crises, because it's usually the biggest problem of this kind of financial market data, that it's very hard to predict crises because they're highly unreliable and unexpected. So you need to actually observe probably even more data, and include in order to also have your in order to estimate your prices better, including political crisis estimation, it's better to use maybe other factors or indicators, political indicators, that will take into consideration crises and other unstable situations in politics. So now we can actually go to demo. I also wanted you to join me when I show you a demo. And during this demo, I would like to predict the crude oil price using an open source data set of Brent crude oil prices using quite simplified LSTM neural network. I actually will add it to my GitHub, so you can later come and play with this. Also, you can, of course, play with different data sets. Like I'm going to use data set on a daily basis, with the data on a daily basis, but you can also use, for instance, prices on a weekly basis or monthly prices, wherever you want. So now I think I will need to go here. Yes, I will start it. So now I moved to Jupyter Notebook, and I will restart my kernel. Yes, I think I will also restart my kernel. Sorry. Yes. So yes, my kernel is restarted, and I can actually start with my demo with important libraries, where we are actually doing the stuff. What is this development environment? It's called Jupyter Notebook, and I hope that some of you already worked in this environment. That's actually very handy if you're a data scientist and you would like to try different approaches, like to try different models, and to have a quickly visualization after playing your code. So here, for instance, in the first cell, I load all the very important dependencies and libraries that are required for this demo, like Pandas library, NumPy, Matplotlib, Seaborn, which I mentioned before, and Keras. Oh, yes, for model, we will use Keras. I also downloaded an open source data set, daily crude oil prices, which you can find everywhere, I believe. Of course, you can also use crude oil prices from different brands like Brent or Texas oil or other. And so here, first of all, as I mentioned during my presentation, what we need to do is to prepare our data. Here, what I'm doing, I'm searching for empty cells. Luckily, we don't have empty cells, so we have quite a full data set. The next step is to split our data set into train and test. And that's also what we are doing here. And we just visualized the head of our data set. So we can see that it's almost daily, yeah, almost daily. So we have sometimes like we don't have any data from 4th to 5, but it's actually not very important for this project, because most of the data we have, and maybe the data were not changed during this time, or yes, it has other reasons. But anyway, we will drop all the empty values if there are in a training set, and then we are going to the next step. As I mentioned, normalization is very important, and in order to normalize our data, we use min-max scaler from scikit-learn library. And we actually normalize our data from 0 to 1, so that now all our values are located within the same range from 0 to 1. And So now the next important step is to prepare your data into the format that is needed to fit into the neural network. In our case, we select a window, a window of the values before the one value in future, so that our LSTM layer can learn from 90 points of data before one is being predicted. So we not use one, like in a regular neural network, we use only one historical value to predict one value ahead. And here we have totally different situation. We use 90 historical data. Of course, you can play with this later and use, I don't know, different sizes of this window, but in my case, I use 90. So I will play the cell as well. And now we are getting closer to the model. This model, in this cell, I'm loading the important layers from Keras library, which includes sequential layer, dense layer, LSTM layer, and dropout layer. So here, after loading these layers, we can actually go to the architecture of my neural network that actually has 4 LSTM layers and one input layer, one output layer. Also, we apply dropout layer. What is dropout layer is used for? Well, this layer is used for mainly preventing overfitting, because when you have your model, when you have all the neurons of one layer being trained, they can easily learn too much information, so they can overfit. But providing dropout, it looks like you just hide part of your neurons in each layer. In our case, we hide 20% of each layer, and then these neurons not being learned during this epoch. So that's anti-overfitting measure. So yes, next step is compiling the model. Compiling the model is actually done also using Keras, of course. We use optimizer called Adam, and we use as a loss function, we use mean squared error. Yes, so in our case, I selected only 5 epochs for training because well, we don't have a lot of time during this presentation, right, to train the model, but it's being trained right now, so you can see the result of training this model in several seconds, I would say, well, 2 minutes. And I will also compare it with the results that I will load from the model I trained for 50 epochs, so that you can compare them. But when you, as I told you, I'll add this this demo Jupyter notebook to my GitHub, so you can later download it and play around as you want. So you can also change different parameters. You can change optimizer parameter. You can change a number of epochs, batch size, and yes, this probably also will have an impact on the final result. So it's very interesting to play around it and to actually dive into and to receive more understanding on this, because you will understand how a neural network works only after you actually tested it and play with this. Well, now it's training, and I see that it's actually quite dark in my room, so I better turn on the light. And now the last epoch has been trained. I also would like to say a few words about batch size. Actually, batch size is also how much your data samples is being taken by model and moved from move through all layers in one step. So you can also play with this number and change it. And to change more predefined parameters, you can also visit Keras webpage and see all the other parameters in documentation. So yes, it is finished. And now we can actually load the model. Well, I will load the model a bit later. First, I will make predictions with the current model. Before making the predictions, I will just prepare a testing part of my data set. And because we also need to prepare this part to be easy to consult by our neural network, so that it also has the same structure. It also need to have 90 the window with a length of 90 values. So now we can actually, yeah, it's not loaded, of course, because it's a different model. Yes, so now we're making a prediction with our model that is just trained. Now we can actually receive visualizations. Oh yeah, it even shows something. Oh, nice. So here we can, well, I maybe will make it a bit smaller. Here we can see the predicted values and original data for crude oil prices. You see that actually you have the predictions are quite good, but they are not very precise. So we have some gaps between the predicted values and original values, especially in the beginning, in the first part of our testing set. Yes, on this graph I visualize only testing set. And it will be actually interesting also to see how it looks like on the whole data set all together with the testing data and training data. So here we see that about first several thousands values we used for training, and the rest of the data we used for predicting, for evaluating our model. And here you see the red color. It's actually our predicting values. So yeah, that's how it looks like. But what actually happened if I will load the model? Load the model which I trained for more epochs. So let's do it and check. Okay, I just will. Okay. What we see? Wow, what's a great result. You see, immediately all the gaps eliminated. So that means that actually in this particular case, the number of epochs had a very big impact on the final result. And here we also can see it. I almost cannot see the red color here. So that means that the values are really close to each other. In this demo, I didn't make any comparison in means code error and the comparator of these characteristics, but you can make it when you will play with this Jupyter notebook. Yes, I think that it's actually quite an end of my presentation. Well, it was come to the end again. That was yes, it was really a real pleasure for me to present this this project together with the demo. My main purpose was to show you that there are several very important moments when you deal with these projects. One of them is collection of the right data, and that you and your client understand what data is relevant and very important for predicting the prices. And also, I wanted to show you that actually the more you can easily apply this model to the right data and get good results. For instance, we had quite clean data because it was from the brand, and we easily built we easily received quite good results. But if you have if you have not very clean data and not prepared data, irrelevant data, that can lead to that you can probably will have some problems even with a perfect model. So yeah, this is the end.
Cool. Thank you very much for your talk about your deep learning project. So I do have a couple of questions from the audience. So Daniel Costa is interested in the seasonality in time series data. So he's wondering what happens if you can't detect seasonality in your time series data? How can you solve that actually?
Well, seasonality, it's actually not a problem. So how you can detect seasonality? Seasonality, well, you can check seasonality when you see that, for instance, well, in our case, there are not so much seasonality because you saw that during the time, well, if I will go back to our crude oil graph here, right? You see that actually during the years, because here we have time, during the years, the trend is going up. So there are no particular seasonality. But for instance, if you deal with a data set like, well, let's say prices for Christmas tree prices, right? So Christmas tree prices obviously will increase during Christmas. So you can see clear seasonality in this data. And for this data, it's very important because if you would like to predict Christmas tree prices, then seasonality is a crucial moment. But for our crude oil prices, it's not very important because, as I mentioned before, for crude oil prices and for other financial market prices, there are more important factors like politics, economical factors like economic wars between different countries. Yes, this is the moment. So you always need to see the background when you estimate these characteristics like seasonality and others.
Yeah. So so you're using actually visualization to detect seasonality in your data set. Is that what you're doing?
Yes, you can use visualization. Also, of course, you can use other approaches. But I mean that Yes, you can use some thresholds, for instance, and calculate it by other mathematical ways. But I mean that you always need to see what characteristics are important to estimate in your situation with your data, because all the data is different. As I told, for Christmas tree prices, it's crucial to use the seasonality characteristics. But for crude oil, we actually, well, it's not very important.
Yeah. Cool. So I hope, Daniel, that answered your question. And Daniel's actually responding to us in the live chat. He says, so if you have seasonality, you use it to better predict data. Otherwise, leave it out and don't worry about it, especially in this case, since you're working with crude oil, where politics, things like wars and production values actually matter more than seasonality. That's good. Another question that we got is, so you've shown us a very cool notebook with a lot of visual stuff in there. Is this based on open source datasets, and can people download it from your GitHub profile by any chance?
Yes, I will actually add it well, today or tomorrow to my GitHub to make sure that it is there. And I think that I can also add it with this data set because it's open source. You can actually download it from government organizations who sell it, like who sell this oil, like from Texas organization, VTI Oil and Brent. I think that yeah, it's an open source. So, but yeah, the only way that probably if you download them directly from these sites, these websites, maybe they're not prepared with yeah, but it's not a problem. I think they are very simple. They only include one variable, and it's quite enough for LSTM layers. Although you can use multiple variables, but yeah.
Cool, sounds awesome. And so if people want to get started with this kind of stuff, is there any particular book or tutorial you can recommend to people that they should read or watch to learn this kind of stuff?
Well, I would recommend to read actually. Well, I know that the guy Andrei Karpathy from Tesla. Maybe you heard about him. He's CEO of AI in Tesla or something like this, director AI. He wrote quite an interesting post about time series data. But I think that actually all the time series data related articles could be useful on the first stage, because you actually need to understand how to deal with time series data, what are important, and what more you need to not just to apply all kind of data, but you first need to understand your data to understand if all the variables are relevant, if you collect enough data, or maybe you need to exclude some data. As I mentioned, for this reason, you just can apply correlation matrices. It's very easy, and I also recommended library in Python that you can use, Seaborn. So that's yeah, that's actually what you can start with. But also why I recommend Keras for beginners. It's a very easy library, and you saw that it doesn't take it takes very little amount of lines of code. So you don't have to write I don't know 100 lines of code in order to create a new model. You just call several layers and that's all. So it's very easy to understand. And yeah, so that from that perspective, you also can read Keras documentation. Yeah.
Cool. Yeah, so thank you very much. Yeah, I would imagine that people spend a lot more time waiting for their computer than actually writing the code to build this neural network. So that's good to see. So if people are interested, they can go up to your GitHub profile and get the code from there. It's actually in the slides, and we'll share the link afterwards as well. So with that, I'd like to thank you very, very much for your talk and for your time tonight to give us a presentation and have a chat with us about deep learning. For people that are interested in more content, we do have another AI talk coming up on April 27th. And Mia Chang is going to join us then, and she's going to talk about the 7 steps in AI application development. So she's going to take us on a tour. How do you start analyzing a typical AI problem, and how do you build a solution for that? It's more of a process talk, I think, but it's very, very interesting, I can assure you. And with that, I'd like to thank you all for watching today, or maybe later if you're going to watch this on demand. And I wish you all a pleasant evening.
Thank you very much.
Hey, my name's Akanksha.